Hello everyone and welcome back to the CloudGuard Portfolio project. This project is the project 39 and today we are diving deep into IPv6-Enabled dual stack architecture in AWS. In this video we are designing a production style dual stack Amazon VPC that supports both IPv4 and IPv6. You will learn how to securely connect public and private workloads, enable IPv6 connectivity, and also understand why components like the Internet Gateway and Egress-Only Internet Gateway play different roles. As the internet evolves, mastering IPv6 while maintaining IPv4 compatibility is no longer optional. It's essential for modern cloud infrastructure. The question is, why the push for IPv6? IPv4 addresses are running out, leading to complex NAT solutions and operational headaches. IPv6 offers a massive address space, simplifying network design, enabling end-to-end connectivity, and paving the way for massive IoT deployments. A dual stack approach ensures a smooth transition, allowing your existing IPv4 applications to run seamlessly while new services embrace IPv6. Our dual stack solution is not just about technology, it's also about GRC compliance. By simplifying IP management and enhancing network segmentation, we also align with the frameworks like NIST CSF, ISO 27001, PCI DSS, and HIPAA, providing a more secure and auditable network environment. Let's jump into the architecture and I'll show you what we're going to be building. But before we do that, if this is your first time on this channel watching this series of videos, please like and subscribe so YouTube can recommend these videos to multiple people to watch. I'm trying to build a community here where we teach each other by building projects. Having said that, please like and subscribe and also share this video with family and friends. Let's jump onto the architecture and then I'll walk you through the architecture. So now let's explore our dual stack architecture. We start with the VPC, configured for both IPv4 and IPv6 blocks. Within this VPC, we create public and then private subnets, each supporting both protocols. For internet access, we're going to be using Internet Gateway for IPv4 traffic, which is right here highlighted in blue, and then Egress-Only Internet Gateway for IPv6, which is right here with the broken arrows. The Egress-Only Internet Gateway is key here because for private subnets, allowing outbound IPv6 connections while blocking unsolicited inbound traffic is very paramount. And that is where Egress-Only Internet Gateway here comes into play. It allows just your subnet or applications in your subnet to communicate with the internet, but without allowing the internet to communicate with it. Serves the same purpose as the NAT gateway for IPv4. Our EC2 instances are going to be launched with dual stack network interfaces, receiving both IPv4 and IPv6 addresses. Then the most important part is going to be our security group. Our security groups control traffic for both protocols. So here, as you can see on the application layer, we have the HTTP from this CIDR range, and then we also have this for the IPv6 and all ICMP from anywhere on IPv6. So it's supporting both protocols. So the traffic flow is going to be like this. Any user or any application connecting using IPv4 or IPv6 will have access. Users connecting to the public instance can connect via either IPv4 or IPv6. If it's IPv4, it's going to be using the Internet Gateway, but if it's IPv6, it's also going to be using the Internet Gateway, but our private instance does not allow access via IPv6, only using the Egress-Only Internet Gateway to connect to the internet. And for our route tables, we're going to be configuring our route tables. We're going to be having the private route table is going to route traffic to the NAT gateway, all traffic to the NAT gateway, and the IPv6 traffic to the Egress-Only Internet Gateway. And this is going to be our local traffic. Same here with our local traffic. For public, all traffic to the Internet Gateway and then all traffic to the Egress-Only Internet Gateway. If we are going to be creating other endpoints, then we're going to also configure them to support all protocols in our environment. So having gone through the architecture, let's go ahead and hop into the AWS console and then go ahead and build. In the AWS console, we're going to begin by creating a new VPC and associating both IPv4 and IPv6 blocks within the VPC. So let's go to VPC Go ahead and create VPC, and we're going to name our VPC and then our CIDR. And then right here, make sure you click on Amazon provided IPv6 CIDR. For the network border group, we're picking the US East 1. Go ahead and create VPC. This VPC establishes the foundational network for our dual stack environment, providing both the IPv4 and IPv6 address spaces for our resources. So as you can see here, we have the IPv6 associated, and we also have the IPv4 here. So next thing we're going to do is to enable DNS host names and DNS resolution. So in the VPC, go ahead and go to actions and then edit VPC settings. Right here we have DNS resolution checked. Also check DNS, enable DNS host name, and then save. So next we create our public and private subnets. So go to subnets. Let's create subnets. The first one we're going to create is going to be the public subnet. So let's go to pick our VPC. This is going to be our subnet name. For availability zone, we're picking our US East 1, and this is our VPC CIDR block, and our subnet is going to be the .1.0/20, and for the IPv6 it's going to be a manual input. And then from this drop down, you want to select this one right here, and this is for our VPC CIDR block for the IPv6. And for the IPv6 subnet, so it must lie within this. So here it tells you how much IP addresses we have, and then come back here and just take it down to /64, and there you have it. Go ahead and add another subnet, and this is going to be the private subnet. So let's name this subnet, and we're going to pick the same availability zone, and this is going to be the CIDR block for our VPC, the IPv4 CIDR block. And then for the IPv4 subnets, we want to go with 2.0.4, and then for IPv6, this is our CIDR block, and then we're going to go to /64 here. So for the first subnets, these two subnets are overlapping. So for the first subnet from our VPC CIDR block, we have this as /64, and then for the second subnet, in order not to overlap, we're going to be changing this last number here to 501 and then to /64, and then let's go ahead and create the subnet. So there you have it. We have the two subnets created. So next we're going to go to the public subnet, go to actions, go to edit subnet settings, and here we're going to enable auto assign public IPv6 and also auto assign public IPv4 address, so that the EC2 instances launched in this public subnet automatically receive a public IPv4 and IPv6 addressing. So you want to come over here and then enable auto assign IPv4 address. Let's also enable the IPv6 and then go ahead and save. Now for the internet connectivity, we have to create and attach internet gateway to our VPC for IPv4 internet access, and for the IPv6 internet access, we're going to create an Egress-Only Internet Gateway. So the first thing we will do is create and attach the internet gateway. So right here under the VPC, come to Internet Gateway, create an internet gateway, and then go ahead and create internet gateway, and then let's attach it to our VPC. This provides IPv4 internet connectivity for resources in our public subnets. So next, let's go to Egress-Only Internet Gateway. Go ahead and create Egress-Only Internet Gateway, and then let's name it, attach it to our VPC, and then let's create Egress-Only Internet Gateway. This provides outbound only IPv6 internet access, which is crucial for private subnets to reach the internet without being exposed to inbound connections. So now that we've created both the gateways, we need to tell them where to route traffic to. So we need to create both the public route table and the private route table. The public route table gets routes to both the internet gateway for IPv4 and the Egress-Only Internet Gateway for IPv6. Then our private route table gets a route to the Egress-Only Internet Gateway for outbound IPv6 traffic, and then ensuring private instances can reach the internet over IPv6 without an inbound exposure. So for this, let's go to route tables, and we're going to create a route table, and this first one is going to be our public route table, and then let's attach it to our VPC, and then let's create a route table. Now let's edit routes. So these routes here are all local routes routes, but let's add routes. So this route destination is going to be anywhere, so any traffic should go to our internet gateway, and then let's select our internet gateway we created, and this is for the IPv4 route. And then let's add the IPv6 route. So this, then we're going to select the anywhere IPv6 goes to our Egress-Only Internet Gateway, and then let's select it, and then let's go ahead and save changes. And then for the subnet associations, we want to associate it with the public subnet. So let's select the public subnet, edit association, and then select the public subnet. This route table ensures that resources in the public subnet can reach the internet via both the IPv4 and the IPv6 addressing. So let's go ahead and save. So now let's go back to the route tables again. We're going to create another route table, and this route table is going to be our private route table, and then also our VPC. Let's create, and then let's edit routes, add a route. So since it's our private route table, we're just gonna add the IPv6 destination is gonna be our IPv6, and then we're gonna select the target is gonna be our Egress-Only Internet Gateway, and then we're gonna save the changes. Just like the other route table too, we're gonna go to subnet associations, and then we're gonna edit subnet association, and for this we're gonna associate this with our private subnet, and then save changes. This route table allows resources in the private subnet to initiate outbound IPv6 connection to the internet while also remaining isolated from inbound internet traffic. So the next thing we're going to do is to launch instances into our public and then private subnets to ensure that we are configured for dual stack operation. But before we launch the instances, we're going to create security group that allows SSH and then HTTP traffic for both IPv4 and IPv6. This ensures we can connect to them and then test our web servers that we're going to be installing on the EC2 instances. So let's come to EC2 console. Let's go to security group, and then let's create security group, and then let's name our security group. Let's pick our VPC. For the inbound rules, let's add inbound rules. First one we're going to add is SSH, and the source is going to be from anywhere IPv4, and then let's add another SSH rule, and this one the source is going to be anywhere IPv6. That covers the SSH for both protocols, and then let's add HTTP2 for both. So let's go to, this is going to be HTTP, and then for anywhere IPv4, and then HTTP again for anywhere IPv6. And then for outbound rule, we're going to just leave it as allow traffic as default. This security group allows us to connect to our instances and test web services over both IPv4 and IPv6. So here let's go ahead and create the security group, and now it's time to launch our instances. So let's go to instance, let's launch instances, and the first one we're going to launch is going to be our public instance in our public subnet. So we're going to name our instance. I'm going to stick with the Amazon Linux. T2 micro is fine. We're going to create a key pair and then go ahead and create. And then for networking, just go ahead and edit. Let's pick our VPC, and then we're going to be picking our public subnet, and then auto assign IPv6 and IPv4 is going to be enabled. For security group, we're going to pick our existing security group, and then let's go down to advanced details. We're going to be adding our user data. I'm just going to copy my user data here and paste, but we're going to be making some changes. Since this is Amazon Linux AMI that we're using, we're going to be using DNF instead of YUM. Change all the YUM to DNF. Okay, this is our user data. We're going to be saying hello from public dual stack instance, and then let's go ahead and launch the instance. So now let's go back to instances, and then let's launch another instance. This time we're going to be launching this one in the private subnet. So let's go ahead and launch instances, and then I'm going to name my instance. We're going to use Amazon Linux. T2 micro is fine. We're going to proceed without key pair. Let's edit, pick our VPC, and then pick our private subnet. We're going to disable auto assign IPv4 public addressing here. For the security group inbound rule, I'm going to be connecting to this instance using the SSM session manager. So I'm going to add a route. I'm going to add HTTPS from anywhere, and then for the user data, I'm just going to add the same server for the public subnet and just go ahead and launch the instance. This instance will demonstrate outbound IPv6 internet connectivity from a private subnet while also remaining isolated from inbound internet traffic. So for the public subnet, let's see if we can connect to it. So let's select it, let's connect, and we're going to be connecting using instance connect, and then let's connect. Here we are in our instance. Let me make sure my Nginx server loaded accurately. So let me just check. So there you go, it's active. Now to test our IPv4 and IPv6 connectivity from the public instance, let's go ahead and call ifconfig.me. And there you have it. We have our IPv4 address, IPv4 instance. So there you go. This is 44.192.107. If you come to our instances, the public instance, there it is. If we try to curl, let's say google.com. So there you have it. Our IPv4 is working correctly. And here the 301 move is an HTTP redirect, which is just saying Google server is responding by saying I've permanently moved to google.com right here. So this is a completely normal behavior. Google redirects the bare domain to its www.google.com, which is good. So this explains that our IPv4 address is working. Now let's try our IPv6 address. So same thing, we're going to curl -6 ifconfig.me, and there you have it. This is our IPv6 address. If you come over here, this is our IPv6 address. 815 is the last digit. So if you check again, 815 is the last digit. Now let's crawl google.com using the IPv6. So Google, and there you have it. We have the same redirect again, redirecting us to google.com. This explains that our IPv6 addressing is working perfectly. This confirms that the resources in the public subnet have full dual stack internet access. Now for the private instance, to test the private instance, we will need to either use a bastion host. We can also use our public instance, or we can use AWS SSM session manager. I'm going to be using AWS SSM session manager for this. So let's go back to our instance, and to be able to use that, we need to add the role and also create endpoints for it. So if I come to it now and try to connect, it doesn't have a public IP address, and if I try to use session manager, it's not going to connect because we need to set up identity. So we need to add a role and also set up endpoints. So I'm going to do that, and then we'll connect and test it out. So for that, I have a role created already. So I'm just going to come to my EC2 instance, and then actions, go to security, modify IAM role, and then I'm going to attach the IAM role I created, which is going to be the instance role, and then go ahead and update IAM role. That is 1. I'm going to also create a security group mainly for my endpoints. So I'm going to come to security group. I'm going to create a new security group for my endpoints. I'm going to pick my VPC. Inbound rule, I'm going to allow HTTPS. I'm going to say from anywhere, and then create security group. So the last thing I need to create now is the endpoint. So I'm going to come to VPC, come over here to endpoints, and I'm going to be creating 3 different endpoints. So let's name this one 1. It's going to be for AWS services. And if you come over here, let's search for SSM. So the first one is going to be for Amazon AWS.US East 1. I'm going to select my VPC. I'll select my subnets, and this is going to be my private subnet. And then for the IP address type is going to be dual stack, and then let's select our security group and then create endpoints. Let's add the second one, and then this is going to be the EC2 messages. Select our VPC, and then our subnet. Let's select the private subnet again, private dual stack, and then our security group, and then create it. Now for the last one, and then the last one is going to be the EC2 messages. Select my VPC endpoints, and then go ahead and create. So these are my endpoints. Let's allow them to be available. Meanwhile, let's go back to our instance. I'm just gonna reboot this instance. So go ahead and go to instance, states, reboot. So just give it about 5 minutes to reboot, and then we try and test it out and connect again. Our SSM session manager is ready. Let's go ahead and connect to our private instance. And there you have, we have connected to our private instance. Now to test, we're going to ping our public instance private IPv4 address, and then let's go back to instances, and this is our public instance, and then we're going to copy the private IPv4 address, and then let's come back to our session manager in our private EC2 instance. Let's first of all ping it, and this is it right here. Let's go ahead and ping it. Now this ping is probably not gonna work because we didn't allow ICMP, so that's fine. Let's cancel that. Let's go ahead and curl and see. There you go. It tells you hello from our public dual stack instance, and this is our Nginx server from our IPv4 in the public instance. Now let's go ahead and attempt to call the ifconfig me. So let's go ahead and call. So this is gonna fail because there is no IPv4 internet route for this EC2 instance. So this explains to you that it doesn't have internet access. The only internet access it has is through the IPv6. So let's go ahead and cancel this. Now let's verify our IPv6 connectivity, outbound connectivity. So for this, let's curl. Our call for IPv6 ifconfig.me failed, and this is expected because this is supposed to call back to the instance, and because we are not allowing inbound connection, this is going to fail because this calls back to the instance. But this is why the architecture is good, because Egress-Only Internet Gateway doesn't allow inbound access, and this is it. So to test our IPv6, let's see if we can call this site that supports IPv6 outbound test only and see if it's gonna work here. It failed to connect. Let me just make sure we have IPv. Let me check my instance. Let's see the private instance. We don't have IPv6. We don't have an IPv6 associated. Let's go to the subnet. Let's go to the private subnets. Let's go to actions, edit subnet settings, and we did not enable auto assign IPv6 address. So let's save. So for the public instance, I have my IPv6 address, and then for the private instance, I don't have my IPv6. That's why I can't connect. I'm gonna stop the instance. Okay, now that instance is stopped, let's go ahead and restart the instance. But for our public instance, we can connect to the web server that we installed. We can connect to the web server here, and there you have it. Hello from our dual stack instance. And then for the IPv6, we can connect to it too. But the only difference is we have to include the IP in a square bracket and then go to it. And there you have it. So now let's go back in and test our private EC2 instance. Now that it's running, let's go ahead and connect to it. Still doesn't have the IPv6. Let's connect to our private instance and then connect. So we're in a private instance here. Let's go ahead and call the private IP address of our public EC2 instance. So this is a private IPv4 address. Let's copy it, come over here and then curl, and there you have it. This is coming from our public dual stack instance. And then let me see if I can curl the IPv6 address. And there you have it. Here is a complete walkthrough of an IPv6 enabled dual stack architecture on AWS. You've learned how to build a future-proof network that balances both the modern IPv6 adoption with essential IPv4 compatibility too. For the next project, I will strongly advise you leave this running because we're going to build upon this for the next project. So for the next project is going to be the network performance monitoring. So leave this stack on because we're going to be enabling some features to be able to monitor the traffic. So the key concepts and consideration for this architecture is that IPv6 address space provides an enormous address space, eliminating IPv4 exhaustion concerns and simplifying network design without complex network address translations. The Egress-Only Internet Gateway is a key component for IPv6 in a private subnet because it allows instances to initiate initiate outbound connections to the internet, but prevents inbound connections, which enhances security here in AWS. The dual stack benefit here is the fact that it allows a gradual transition to IPv6 while maintaining compatibility with existing IPv4 systems, right? So applications can communicate using whichever protocol is available or preferred by the application. So we want to also remember to configure the security group rules for both the IPv4 and IPv6 address to ensure proper traffic control. And then the DNS resolution. So we want to make sure we ensure the VPC has DNS host names and resolution enabled for a proper IPv4, which is the A record, and then the AAAA record for the IPv6 resolution. So for the cleanup, leave everything as is. You can complete the next project, which is the network performance monitoring, and then you can now clean up. Thank you for watching this project. See you in the next project, which is going to be a continuation of this project. Thank you for watching. Please subscribe and follow for more projects coming. See you in the next project.